Welcome to part 3 of the PLAST2bCLEANED e-learning, this time on KER Key Exploitable Results number 4 on the open access facility that we developed for the recycling of polymers, bromine, antimony, trioxide from secondary plastics from current and future waste products. So this will be a joint presentation by me, Annemieke van der Runzet. I'm from TNO, and Sebastian Reinhardt from Fraunhofer ICT. The facility is based on the process that we developed in the previous e-learning, so on TRL 4. This is TRL 5 plant on kilogram scale, but it will has the same processing steps. So the sorting of the waste, coarse filtration, dissolution, sedimentation, hot filtration, spray drying, and evaporation. We will go through all the different steps to show how we implemented this work. So the process starts with the waste and adding that to the plant. You see on the right the plant, and in red is indicated where the dissolution vessel is. So in the sorted plastics, there's all kind of more coarse material. So we add the waste with the solvent and start dissolving the target polymer, in this case ABS. And in a next step, when the polymer is dissolved, we look at filtration. I will start if Sebastian will start. Exactly. So you see here a top view of the dissolution process, where we just stir the waste with the solvent, dissolve the ABS, and use the filter that's underneath the vessel to remove the bigger undissolved materials. So after the coarse filtration, the next steps are designed to clean up the ABS even more. And Sebastian will take over to explain how we do this.
Thank you, Annemieke. The next step is to remove the antimony trioxide, which has a density of a higher 5 grams per cubic centimeter. This means it has a higher density and settles down to the lower end of the next tank. And with a dip pipe next, we can remove the upper phase that we call supernatant, which has a lower amount of antimony trioxide, but still the dissolved polymer and the dissolved bromine flame retardants. And this is moved to the next tank, which is the membrane filtration tank. In the membrane filtration tank, we still have a mixture of dissolved polymer and bromine flame retardants in there. And what happens next is that we run this material over a membrane, a ceramics membrane, that is able to sort of remove by size the bromine flame retardants. They go through the membrane and are removed thereby through the permeate, which is the liquid that goes through the membrane. And then only purified polymer remains in the concentrate. How does that work? The scheme in this slide shows you that the polymers, in our case ABS, have a magnitude of, let's say, 200,000 to 300,000 grams per mole, while the bromine flame retardants are in the magnitude of 1,000 grams per mole, roughly. And this is shown in the scheme. So the small molecules can go through this filter, while the polymer is retained and has to stay back in the concentrate fraction. On the lower end, you see the pictures. On the right-hand side, you see this sort of purple discolored permeate, which is very rich in bromine flame retardants, whereas on the left-hand side, you see this grayish oily liquid, which is our purified polymer still dissolved in the solvent. And that goes into the next step, which is the spray drying unit. As we mentioned before, when you want to dry polymer that is dissolved in solvent, usually it tends to well form a skin and solvent pocket, so it's not very easy. But the spray drying we found is a very good solution for that. Here the purified polymer is dried and pushed through a nozzle at elevated temperatures. Small particles form, and the recycled ABS can be easily reused and has a remaining solvent content of less than 0.5%. This dried recycled ABS, later on we compounded it within the project and made some test bars, and it's already passed the current REACH and SVHC and POP regulation tests. And the next step in the project is to make some washing machine door frames as prototypes. The whole facility you have seen can be visited at the Fraunhofer ICT site near Finstal in Germany. Here you can see a bird's view over the place, and well, on the top right-hand pictures you see that the TRL5 plant and the spray drying unit are situated in the different buildings.
Thank you for attention. If you want to know anything more about the facility of our project, contact Sebastian or his group leader, Ronnie Heinig-Span on the pilot, or me on the process, or our coordinator Esther van der Beuken, who's also principal consultant for circular plastics.